So 4.3, graph quadratic functions in standard form. There's several notes we have to take before we can actually start this. The first thing we need to know is we have standard form for a line, right? Who can tell me what standard form for a line is? A line.
Standard line.
A standard line, it's AX. What did we know before? For regular lines, AX
X² plus BX²
plus BY equals C, right? That's standard form for a line.
How does that equal a line?
Okay, this is standard form for a line. We have a number in front of X plus a number in front of B. Both A and B are on the same side, and they equal another number C. How do we graph a line in this form? Does anybody remember?
I don't even know how that makes a line.
We find the x-intercept and the y-intercept. How does it make a line? There's an x and a y. You find the x-intercept by plugging in 0 for y. You find the y-intercept by plugging 0 in for x, and you graph them. It makes just a line, just a straight line. A stands for a number, B stands for a number, C stands for a number. Okay? Now, standard form for quadratics is a little bit different. It's kind of what we've been working with already. You know, on a standard form for a line, we have x and y on the same side. Same thing on, or something similar on quadratics. We have all of our x's on one side. So standard form for quadratic, y equals a, which is a number, x squared plus b, which is a number, x, plus c, which is a number. So a standard form is when all of our x's are on the same side of the equation for a quadratic. Okay, so that's our standard form. Now remember, the graph of a quadratic function is called a parabola. So definition of a parabola is the graph of a quadratic function, and we have some things that we need to know about it. So this is what I just drew, some parabola. It's always shaped like a U. In this example, it's curving upwards. Okay, and there's a couple things about the parabola that we need to be able to identify. All right, the line of symmetry, well, let's start with the vertex. The vertex is the point where the graph curves, right? So in this case, it's the very, very point where the graph curves. It is either going to be a maximum or a minimum value. In this case, we have a minimum value because it's the very smallest value on the parabola. How would we get a maximum value? If it was upside down. So if it's upside down, we would get a maximum value because it would be the highest point on the parabola. Okay, so that's the vertex. We also have what's called the line of symmetry that goes straight through the vertex because the vertex is in the middle of the graph. The line of symmetry means that everything on this side is exactly the same as everything on the other side. So it's like a mirror. So you could fold along the line of symmetry and we would get the exact same thing. Parabolas are symmetrical. Okay? So let's see. Let's look at that. So the vertex, or here. The vertex is going to be a point x comma y. If you are asked to find the minimum or the maximum value, it's just going to be what the y value of that point is. Okay, and the line of symmetry is going to be y equals a number in this case because it's a vertical line. So it would also be y equals whatever the point on the vertex is. Okay? Alright guys, so we're going to be asked to find these things a lot of times without graphing. So how do we find, or we're also going to use them to graph. So how do we find the vertex? Okay, the vertex is a point, x comma y, so we need to be able to find the x coordinate and the y coordinate. So we do have an equation for finding the vertex. To find the x coordinate, we have x equals negative b over 2a. So x equals negative b over 2a. Where do the b and the a come from? Any ideas?
From the standard form
Exactly, from the standard form. So I'm going to pull this down really, really quick. Okay, so the b comes from whatever's in front of x, and the a comes from whatever's in front of x squared. So we're going to take those coefficients and plug them into this equation to find the x-coordinate of the vertex. After we find the x-coordinate of the vertex, we just plug it back into the original equation for x, and we solve for y. So we just substitute it back in.
Which equation? After standard form.
The standard form.
Okay.
We use a and b from standard form to find the x value. Once we find the x value, we plug that back in to the equation, and we'll be able to solve for y. And that's going to give us the point of the vertex. So we'll be able to graph one point on the parabola just from the equation. Okay, now our line of symmetry, if you look at the graph, runs straight through the vertex, because the vertex is either the lowest point or the highest point on the graph. Okay, so our line of symmetry runs straight through the vertex because everything through that point is going to be symmetrical. Okay, so how do we find the line of symmetry? Well, that x-coordinate of the vertex is going to give us the value of the axis of symmetry. Okay, line of symmetry, axis of symmetry is the same thing. Alright, so that x-coordinate is going to give you the value. So remember how I told you that the line of symmetry is y equals a number? That number is going to be the x-coordinate. Okay? So the number x, whatever number we get, is going to be the line of symmetry, the equation for the line of symmetry. Okay? Okay, we need to know a couple things about the graph. Okay, if a, which means this a right here in front of the x squared, if that a is greater than 0, which means it's positive, so if a is positive, then we're going to get a minimum value because it's opening upwards. Okay? And that minimum value is the y value of the vertex. If a is less than 0, which means if a is negative, our graph is going to open downwards, so we're going to have a maximum value. And that maximum value is going to be the y value of the vertex. Alright, so now we have some steps to graphing, and then this is it, and we're going straight to examples. Okay? So, steps of graphing. Step 1, we need to label A, B, and C, and state whether the graph opens up or down. So we're going to look at our equation and right away figure out if our graph is opening up or if it's opening down. Step 2, we find the x value of the vertex. So we use that equation, x equals negative b over 2a. And step 3, we find the y value of the vertex by plugging in the x value to the original equation. Alright, a couple more steps. Okay. Step 4, you need to state or find the line of symmetry. Alright, which is just the x-coordinate of the vertex. And then step 5, you sketch the parabola and draw the line of symmetry. So we're going to be able to sketch the parabola, and we draw the line of symmetry straight through the middle. Fulls. For the next two examples, examples 1 and 2, we are going to identify the line of symmetry, identify the vertex, we're going to sketch the parabola, and then we're going to state if the parabola has a minimum or maximum value and identify it. Now, when we're sketching a parabola, we're just sketching, so all of our points don't have to be exact. Alright, we're just going to sketch the parabola through the vertex. Okay, so let's look at example number 1 here. Alright, so example number 1. Part A, I want to identify the line of symmetry. How do I identify the line of symmetry? It's the x-coordinate of the vertex. So in order to identify the line of symmetry, what do I need to find first? The vertex, right? So let's find the vertex. Okay, so to find the vertex, I'm going to label it. The x value equals negative b over 2a. So that equals, what's my b in this case? Negative 6. So we're going to have negative 6 over 2 times a, which is 3. So to find the x value of the vertex, I have negative 6 over 2a, or which is 3, sorry, over 2 times 3. So that equals what? Negative 6 gives me positive 6. 2 times 3 gives me 6. So my x value is 1. So my x value of the vertex is 1. How do I find the y value? I plug it back into the original equation. So to find the y value of the vertex, I plug it in, so I would get 3 times 1 squared minus 6 times 1 plus 4. 3 times 1 squared is just 3. 6 times 1 minus 6 plus 4. Three minus 6 is negative 3 plus 4, and negative 3 plus 4 equals 1. So my vertex is going to be the point positive 1, positive 1. That's my vertex. So let's plot that point right now. Alright, so my vertex is at 1, 1, so my point 1, 1 is right here. And now we want to find the line of symmetry. So I'm also going to label LOS. And remember, in my notes, my line of symmetry is just the x-coordinate of the vertex. So it's going to be y equals what? 1. So my line of symmetry is the line y equals 1. Yes?
That's 3 minus 6
plus 4. It's 4. I accidentally wrote 3. There. Plus 4. Okay, so my line of symmetry is through the point y equals 1. So let's draw that right now. Line of symmetry is going to be a vertical line. And let's label it LOS y equals 1. I want to label my vertex at 1, 1. And then they just want us to sketch the parabola. So I know that my vertex is at 1, 1, so that's either going to be my minimum or my maximum point. Look at our equation. Is my line or is my parabola going to open up or down?